Morning, everyone. Okay, so the first several sections of chapter 10 we're not gonna bother with. So we're going to talk about translations of functions, and we've actually talked about translations of functions quite a bit in the past, but we're going to kind of focus on that a little bit today. And again, the translations, the nice part about it is the translations of any functions pretty much follow the same patterns all the time. So we're going to go ahead and look at some graphs. We might break out the Desmos here as we go along. We'll see how it goes. All right. All right, so this is section 10.4 or topic 10.4 in your book. And again, these are just problems right out of the book. So we'll go over some of this stuff. But again, like I said, you guys have kind of seen this already, so hopefully it won't be too bad. Okay, so this says sketch the graph of each function. All right, so here's the thing. Absolute value. I don't know how much we've talked about absolute value, but an absolute value function has a certain shape, okay? So like in number 18 there, we have an x squared. X squared, as we know from doing a whole chapter on quadratics, right? The shape of the graph is kind of a U shape. Does anybody know what the shape of an absolute value graph looks like? It also looks like a letter of the alphabet. Anybody remember this or seen this before? Just asking before we kind of move on. No. Okay, that's cool. Okay, so let's talk about this. If this was just x and not the absolute value of x, then we'd have a line, right? So probably Desmos is probably our best bet here as far as to see what these things look like. All right, so let's break up the Des here. All right, Desmos incoming. There we go. Okay, so let's just start off with the graph y equals x. There it is. Easy peasy, right? So what this is this is technically 1x plus 0, okay? So that means since we don't have a number, our intercept point for the y-axis is at 0, right? So that's what that means. And then since it's 1x, that means our slope, we're going to go over 1 and up 1. And then we'll be at, if I can hit it here, 1, 1. Okay, so then it just keeps going like that. But the two numbers match. So 2, 2, 4, 4, that kind of thing. Okay. So what does absolute value mean? What does that tell us when we're talking absolute value? The answer, or the y value, is always what for absolute value? Again, any idea on this one? Okay, so an absolute value means the number is always going to be positive. And one way to think about this is like when you drive your car, okay? So say you're in the car and you put the wrong stuff in your GPS and we go the wrong way, okay? So we've gone the wrong way, but we've still put miles on our car, right? So that's kind of what absolute value is. Think of it as like a distance. It doesn't matter what direction you go in your car, it puts miles on your car. The example I always use, and maybe I've used it in this class, I don't know. There's an old movie from the 80s called Ferris Bueller's Day Off. I don't know if you guys have seen it or not. If you haven't, go check it out. It's kind of a funny movie, and it's about skipping school, so you guys should like that. Anyway, so this is about a bunch of rich kids that live in the suburbs of Chicago, okay? And the one kid's dad has like a rare Ferrari that only has like 100 and some miles on it, okay? And so Ferris is the main guy. He convinces his buddy to take his dad's Ferrari out and go into Chicago. And they go to Chicago for the day. Well, they park the car in a parking deck. And then they go about the city and they go about and do the thing. Well, a couple guys that work at the parking deck decide to take this car for a joyride. Okay, so when they come back at the end of the day, um, they're looking down at the odometer, which is tells you how many miles you have in your car. And also, this car's got like 300 miles on it, and the one kid is freaking out. Okay, so what they try to do when they get the car back to the house, they jack up the back end, they put it in reverse and start running the car, hoping that the miles will come off. Yeah, that doesn't work. So again, if you're going in reverse in your car, even though you're going in reverse, it will still put miles in your car. That's the point of absolute value. It's always a positive number. Okay. So how would that affect our graph? So over here, we know like, okay, we were clicking on here and we said, all right. So like here, if x equals 4, y equals 4, that kind of thing. If we go this direction, like here, we got if x equals -2, y equals -2. But what we're saying now is if you take the absolute value of -2, so we went 2 miles in the wrong direction, but we still put 2 miles on our car, right? So all the y values are going to be positive. So instead of this being -2 minus 2, this will become -2 plus 2. So that's up here, right? Let's actually put that point on here, and you'll see what happens here. So let's go ahead and do -2 and plus 2. Label that guy. Okay. So now we're up here instead of down here. So that means when we get to this point, our graph's going to start doing this. Okay. So check this out. We'll put in the absolute value signs here. And notice our graph now on this side goes up and went right through the point that we put on there, didn't it? So that means our graph is V-shaped. Okay. So our graph is now V-shaped. So let's go back to our problem here. So this says absolute value plus 6. All right. So we got a plus 6 here. Now, how does that move our graph when we put the plus 6 in there? How does that make our graph go? That's right, Chloe. The graph moves up 6. And Dummy here didn't realize that he had hit his mute button. So then what we're going to get is instead of the graph bottoming out at 0, 0, the graph's going to bottom out at 6. And then it's going to be this V shape. So just a quick thing what that looks like is right there. Right? I don't know how I keep doing that. Thank you, Chloe. So again, the x squared is going to be a U shape, right? And then we've got the -3 here. So how does that move our graph? So over here we had a +6. That moved us up 6. What's this guy going to do? We have a -3. Yeah. So same thing. So let's go back to Des for a second. So this time let's do x squared. So get rid of this guy, and get rid of this guy, and then this one is going to be x. Okay, so there's our U shape, and same deal. So the absolute value had bottomed out at 0, 0, and so does the x squared. Because again, these guys are both positive. Even on the negative side, we're still positive, right? So if we plug in -2, if you square -2, -2 times -2 is +4. So you can see these guys are kind of similar, right? And then, as Chloe predicted, if we pop in a -3 here, our graph goes from 0, 0 down to 0, -3. Why x squared? Well, that's just what they gave us. So x squared is just x times x. It's the number times itself. The reason it's always positive is when you take two negative numbers and multiply them together, we get a positive number, right? So as I had shown you there, if we had -2, -2 times -2 is +4. 2 times 2, also +4. So these guys are very symmetrical. I'm not quite sure if that answers your question, Chloe. I'm not quite sure what you wanted to know there. So if you remember some of the basic shapes of these things, that helps. And I'll try to post something that has like what they call the parent functions, which is the most basic of each of the functions. So as you saw, an x squared function is U-shaped, a absolute value function is V-shaped. Okay. So again, that's our guy. So the same deal here. If we were actually drawing this thing, we come down to -3. And then, let's see, that's 1, 2, so there's 3. Then we kind of do the U-shaped thing if I was actually drawing something. So we come down to -3, kind of do U-shape, something like that. Less than perfect, I know. Okay, so that's the kind of stuff that's going on here. Questions? Okay. Let's check out a few more graphs. Okay, so this is a linear graph. They're pretty easy. So what we do here, the way you plot a linear graph is we start at this number. And this number is always on the y-axis, which is right there. So the vertical or the y-axis, okay? So even before we know what our graph looks like, we know that that +2 means that we're going to move up 2. So we're going to start right here at 2. I'm trying to hit it here. This is why I use Desmos all the time. Okay. Then the next thing we look at is the slope. The slope is 1/3. So remember, this is your change in y, or 1. This is your change in x, which is 3. So +1 means from the 2, we go up to 3, and then we go over, or to the right, 3. Oh no, we go up 1 and then over 3. So up 1 and over 3 is about there. Okay, and then we just connect the dots. Well, we try to connect the dots anyway. So again, let's check out Des. So in this one, we're just going to have a plain old x. But again, you can see how this changes, right? All right, so there's our x. Now, if we add 2, we're going to go up 2, right? So there you see we went from 0, 0 up to 0, 2. So it moved up 2. And then when we put the 1/3 out front, so from 2, we're going to go up 1 and over 3. So that's going to be over here, right? So let's go ahead and pop that in there. So if I'm at 2, 0, right? So I'm at 2, 0. I'm going to go up 1 to 3 and then over 1, 2, 3. So he's going to be at 3, 3. So let's go ahead and pop that point in there. 3. Label our guy. There we go. So if we put a 1/2 out in front of this, right, let's see if we can do this. Let's see if this works. Divided by, sweet, 3. Oh. So you see our graph became flatter. And now it does go through the point 3, 3. So that's how you figure these out when you're plotting a line. You start with this guy, and the regular number is always where it crosses the y-axis. It doesn't matter what kind of graph it is, what kind of function. If there's just a regular number that's part of that thing, that is where we cross right here. Always. And then from there, we went up 1 and over 3. There's our second point. You only need 2 points for a straight line. So why 3, 3? Because we started here at 2, 0, right? This is our slope. Slope is 1/3. A slope is the change in y. That's the top number. That means y went up 1. So from there, we went up 1. Okay? So if we go up 1 there, then that's going to be 3, 0. Let's put that point in there. 3. I did it the wrong way. It's 0, 3. My bad. Let me fix that. Yeah, because we're not going left to right, so he's going to be 0, right? And then the other point is going to be 3. There. So then we went up 1. So we went from, I forgot to label it. Here we go. So we went from 0, 2 up to 0, 3, right? So we went up 1, that's this guy. Now we're going to go, positive 3 means go to the right 3. So from this point, we go over 1, 2, 3. And all you need is 2 points for a straight line, okay? So that's how we got that guy. And then we can compare that to our original graph, which was just y equals x. Okay, and see the difference here? This guy here was at 0, 0. Now he happens to cross here at 3 also, but notice he has a bigger slope. He's a steeper hill, right? So he's a steeper hill going up. This is a little more flat, but he starts at a higher level. Okay? So yeah, it doesn't hurt to go over that because this is not going to go away. This is going to keep showing up in pretty much every math class you have. Okay? So it's a good thing to get this down now. So that's how you plot a linear graph, is always start with this guy, which is right here. So we put our first point here at 2, 0. Then from here, you say, okay, here's my slope. The top number tells you how much you go up. So we went up 1. Our bottom number tells us, in this case, how much to go right. So that would be over 3. Now, if this was a negative 1/3, here's what you do with that. We'll watch the difference here. So if we had minus 1/3, okay? So notice that it's now going downhill, right? So the difference would be, instead of going up 1, we would go down 1 because of this. And the rule of thumb is take the negative, if there's like a negative 1/3, if it was like out in front of it here, take the negative number and do that for the up and down, because it makes more sense. Positive is up, negative is down. That makes sense, right? And then we would still go to the right 3. So we go down 1, and then 1, 2, 3. So we're over here at what would now be 3, and then down 1. So that would be down here to 1. Instead of being at 2, you can go over 3. You can think of it that way too. We can go over 3 and down 1. They'll still get you the same spot as just going down 1 and over 3. But we end up at the same spot here. Okay, I can get this thing to catch it. There, 3, 1. Okay. So hopefully that's not too basic for you today, but again, it's really important to get through the rest of math that we can work with linears, because that's like the most basic function. And we can kind of build on everything from there. All right. Cool. And again, Desmos is a huge help as usual, right? All right, so let's check out the next guy. Now this is a square root. Holy mackerel. What do we do with that guy? Let's talk about what a square root function looks like. Okay. So first things first, when we're talking square roots, can you have a negative square root? Can we take the square root of a negative number? What do you think? Yes or no? No, that's good. So what that's telling us right away is our x value here cannot be negative. So we can take the square root of 0. That's okay, because the square root of 0 is still 0. So what this is telling us is we can't go for x any lower than 0. So there's nothing going to be going on over here. So we start at 0, 0, right? Okay. Then if you plug in 1 here, so the square root of 1 is 1, right? So we'd have a point at 0, 0. We'd have another point at 1, 1, because the square root of 1 is 1. Well, then we're going to pick our numbers kind of strategically, if you will. Let's not pick 2. Let's pick 4, because the square root of 4 is 2, right? So that means if I go over here to 4, which is right there, the square root of 4 is 2, so that's right here. Okay. Then if we take, because if you take the square root of 4, you get 2. It's an easy number to plot. If you take the square root of 2, you get 1.14, blah, blah, blah. Not so easy to plot. So that's why I'm picking those guys, because they're on the grid. Okay. And then same deal here. If I pick 9, the square root of 9 is 3, because 3 times 3 is 9, right? Just like 2 times 2 is 4. And I'll show you this on Desmos too. So that means we come all the way over here to 9, and we're going to go up just to 3. So the graph is getting kind of flat. It's going to kind of go like this. All right, so let's break out Des. Des will help us out here. All right. So let's go ahead and clear out all this stuff. All right, so let's go ahead and we're going to do the square root. So here's the square root of x. Check that out. Kind of what we were saying was happening. Notice here we were at 0, 0, right? So if I come over here to 1, I can hit it. And I keep missing it. Anyway, you'll get 1, 1. Can't seem to get that one today. All right, so here's what we'll do. We'll go ahead and plot some points. We're going to have 1, 1. So 1, comma. Okay? Because the square root of 1 is 1. So then we said, well, instead of picking 2, we're going to pick 4. So let's do that. 4, and the square root of 4 is 2. Notice that guy still on the line, right? Cool. And notice again, nothing's going on over here because we can't take the square root of a negative number. So there's not going to be any negative x values. Okay, so then let's move the graph over this way since we're kind of working over on this side. So again, let me pick another number. Get back on the graph here. This thing's kind of fighting me here. There we go. Okay. So then we know that the square root of 9 is 3. So I'm going to say 9. Again, look, we're on the graph. Because remember, we're just plugging in numbers for x. X in this case is 9. So the square root of 9 is 3. And then we got room here. We can do one more. So we know 4 times 4 is 16. So the square root of 16 is 4. What that looks like. And we go 16. And the square root of 16 is 4. So again, notice all these points I've picked are on the graph. And again, the reason I picked those was I wanted to have a nice point that I could plot here, 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 and here. So now we've got our basic shape. Now this graph will keep going up, but it takes a long time. You see, it only went up 4, and we're clear out here at 16, right? Okay, so then our original thing, let's go back to our regularly scheduled program. Nope, that's not it. I don't even know what happened there. There we go. Was the square root of x, which we just plotted, right? And then minus 8. So again, what does the minus 8 do for us? What happens when we put the minus 8 in there? Yeah, we're going to go down 8. Perfect. So see, Chloe, how this is? We're on our 4th function already, right? We're on our 4th function, and the numbers still do the same things. This guy made us go up 2. This guy's going to make us go down 8. All right, so let's go ahead and put it on Des since my drawing's terrible. But we get the idea. So again, we come back up here, and we say minus 8, and that drops the whole thing down. I put in 5, didn't I? Oops. 8, there we go. So look, it dropped it way down here. But notice the graph still has the same shape, right? So if I did that, then let's change these numbers. So if I subtract 8 from 1, I get negative 7. Look, he's on the graph. Do the same thing here. I've got 2 minus 8. So he's going to be minus 6. Then I've got 3 minus 8, so he's going to be minus 5, right? And then finally we've got 4 minus 8, that's going to be negative 4. So notice all the points are on the graph again. And I got that simply by subtracting 8 off of each of the y values. And that dropped us down from where we were to where we are now. That's why it drops you down 8, because every single value that you would get when you plug in for x here, you then get a y value that you subtract 8 from. And that's what we did here. We subtracted 8, and all these guys came in. Okay? Questions? Does that make sense? So you see that dropping down 8 was just subtracting 8 off of each of these y points from where our original guy was, right? Cool. And let's see if we got time for maybe just one more, and then we'll work work on this again tomorrow. All right, so what's our next guy? Okay, so now this is x minus 2 squared. Now this is a situation, you've probably heard me talk about this before, where we have a number that's in with the x, and by in with the x I mean like inside this parentheses with the x, okay? And this is the other one when we had it just outside and we just tacked the number on, that moved us up and down. This guy is going to move you left and right. But here's the interesting thing about it. We move kind of the opposite way you would expect. Normally when we see minus 2, we think we're going to go to the left too. This guy goes to the right, and we're going to use Desmos to show you why. Okay? So let's break out the Des. All right, so we'll get rid of these guys. And this guy. Okay, so this one. We've got, I'm going to put a parentheses around this, and you'll see why here in a second. Let's start with what we normally get. So we're going to do x squared. Let's move him back down here so we can see what's going on. Okay? So that's x squared. Now watch what happens when I put in this negative 2 inside the parenthesis. Thing just moved over from 0, 0 to 2, 0. So it moved to the right. Okay? Well, why is this? Why do we go the opposite way? Well, think of it this way. Now we're saying that x equals 2. So if I put a 2 in here for x, right? 2 minus 2 is 0. And 0 squared, 0 times 0, still 0. So that's why we're here. So that's our new graph, and down here I'm just going to put an x squared just so you can compare. Okay, squared. So there you go. So it moves you in kind of the opposite direction of what you expect. So here's the original. He was at 0, 0. Now we're at 2, 0. Okay? And I think that's all there was on that graph. We didn't move up or down or anything. So it moved us to the right 2 positions. So again, when you have something in with the x, that is going to move you 2 units, but not in the negative direction, but in the positive direction. Because think about it. I always thought because this used to confuse me too. And I always looked at this when you had this. I said, well, what number do I put in here for x that makes this thing 0? Okay? And that would be 2. 2 minus 2 gives me 0. That's why this thing moves over 2 to the right. Okay? And again, same deal. Notice here, we go back 1 and up 1 because this would be 1 less, right? So if I put in 1 here, I have 1 minus 2 is negative 1. And then we square it. Negative 1 times negative 1 is positive 1. So that's that guy. And then the same thing happens if I plug in 3, right? 3 minus 2 is 1, and 1 times 1 is also 1. So notice here we're at 1, and here we're at 1. In fact, let me pop that point in there just so we can see it. So then this guy is going to be 3 and 1. All right, so let's label them. Okay? So there you see we have 1, 1 and 3, 1, and they're at the same spot. So we just move this thing over. Okay? Any questions before we wrap it up here? All right, guys, so we'll continue on with this next time. But again, like I said, if we can get this stuff down, here's the thing. We get this down now, this is going to keep coming back in every math class you're in. So if you got it down, when it comes back up in the next math class, you're like, oh, I already know how to do this. I'm good. So, all right. So again, thanks for showing up, and we'll continue this tomorrow.